We're going to work on the lead code problem, unique paths. So this problem is a common Amazon coding interview question. And so basically the problem is you're given a grid and you have a robot placed at the top left corner of it and can move either down or on the right. And so you need to calculate the number of unique ways it is to reach the finish line. The finish line is all the bottom right corner of the grid. So this problem I think was asked during my coding interview as well, and so there are many ways to solve it. I'll do the first way, the way I solved it during my interview, and I was not selected. So I use recursion. So essentially, what I did was I recursively calculated how many ways are there to go all the way to the end of the grid. So what I would do is I would say keep changing the paths from down on the right, and I'll check if the result has been reached, and then I'll count the number of ways to number of times I could reach that result. So yeah, let me demonstrate with an example. So we'll just keep a variable to keep track of the number of paths, and then we'll create a helper method. So this helper method will take a grid. I'll take two variables, which is the row and the column number. So what here we'll do is we'll just initialize the grid. Here m is the number of rows and n is the number of columns. So what we do now is we just say count paths. And since we're starting from the top left, we'll say 0 and 0 as arguments. And then we just say return result. So here, writing the recursive function, like we just need a base case and a recursive case. The base case is we have reached all the way to the bottom right. So here the value of m and n will be equal to, grid.length minus 1. So let me just code that. So if it's equal to the bottom right corner, we'll just increment the result and thus return. So this is a base case. Now we'll do the conditional checks. So if it's a case where you're moving, either the bottom or on the right. So if you have reached somewhere like where the value is greater than the grid size, we need to return. So if m So since you're only moving bottom and right, we don't need to check for negative numbers. So yeah, if you have reached somewhere outside of the grid, we just need to return. There isn't anything to do. Else, we do recursively call this function where we increment either the row size, row number or the column number. So just recap, we are creating a grid equal to the size of the number of rows and columns that have been specified. And we are going to recursively call it and keep checking whether we have reached all the way to the bottom right corner. If we have reached it, we just make a check, we just increment the count of the result and we return it. So yeah, let's try running it. So this passed the two cases here, but you should understand that here the value is 3 and 7. So the number of rows and columns is not that great. So the problem with this solution is that it is exponential. So that every cell we are counting how many ways we can either go left, down or right. And as the number of rows and column increases, the time complexity will also increase. So if I try submitting it, it'll fail. So you can see like the time node exceeded, and that is expected because the time complexity is exponential for that solution. So yeah, for problems like this, you should always remember that there's an easier way to solve it using dynamic programming. And that's what the interviewer is trying to see, if you're able to determine which solutions can be solved using dynamic programming. So yeah, let me show you the other solution. This can be solved using dynamic programming. So in dynamic programming, the question you have to ask yourself is that what are the different ways we can break down the problem? Now imagine here's a cell, here's a grid. So here you're given the specification that can move either bottom or on the right. So if it can move right, like imagine it's of size 1 row and 1 column. There's only one way to reach it. Now imagine there's 1 row and 4 columns. So you cannot move down, you can only move right. So for all the cells, let me just use a pencil. So you can only have one way to reach this. Same way, since the robot can go either down or right, there's only one way to reach, all the way to the end of the bottom. Now imagine, at this point, there are two ways. You can take a right and down or right. So there are two ways. Similarly here, it'll be the sum of the, the row and column above. It's 2 plus 1, 3. So I'm not going to solve it entirely, but that's the logic where, now there are two ways to reach this point. From this point, there's only one way to reach down, and from here all the way here, it can go right, 3. So that's the number of unique ways. So yeah, keeping that in mind, we'll now solve it using dynamic programming. So yeah, let's try coding it. So first we'll code the values for reaching, only one row and only one column. So we're just going to set the values where imagine, so there's only one column and one row, so there's only one way to reach all the way down. So in that case, we'll just say grid. We're going to use the same logic now, but it's for setting if there's only one row but multiple columns. And here it'll be like only one row, the column value keeps changing. So we have calculated the values for, the first row and the first column. So now let's calculate for the remaining side, a grid. So for that, we'll just create a new for loop. So now we have to ask ourselves, so what are the unique ways? So like we said, it'll be the value of the row above it and the, and the column on the left of it. So for that, we'll just say result, a grid ij. So we'll say I minus 1, comma j. So yeah, after we have calculated, we have completed the grid. All the value we have at the last, the bottom right corner, that's the value we need to return. So we just say return. So yeah, for this solution also we'll just recap. We are creating a grid equal to the number of rows and columns that have been specified. And we are first going to fill the value for the case where we have only one column. So that way, the only way to go is go down. So we just set it to 1. Similarly, to go right, there's only one way. So we set it to 1. After, the remaining parts will be the sum of the adjacent cells. So let's try running it. So both the use cases have passed. I'll try submitting it this time. So yeah, for this, the time complexity will be O of m into n, where m is the number of rows and n is the number of columns. Since we are just traversing all the rows and columns once here, and we're using it to populate the grid. The space complexity will be also O of m into n, where m is the number of rows, n is the number of columns, since we're having to create this grid and store values for it.